Find somewhere comfortable tonight. It doesn't have to be perfect. A pillow behind your head, a blanket pulled close, whatever feels like enough. You don't need to follow any of this carefully. You don't need to remember a single word. Tonight, we are going to spend some time with a question that has quietly fascinated scientists, philosophers, and ordinary people for a very long time. What happens to a brain when it goes still? What actually changes deep inside the soft tissue of the mind when a person simply sits down, closes their eyes, and lets the world go quiet for a while? The answers, it turns out, are more beautiful than most people expect. But we are in no hurry to get there. We will begin somewhere old, somewhere ancient and unhurried, and we will move gently from there. There is a word in Sanskrit. That idea, the gentle act of returning to now, is older than most things we consider ancient. The earliest written accounts of meditation practice appear in Indian texts called the Vedas, composed somewhere around 1500 years before the Common Era. That is roughly 3,500 years ago, long before most of what we think of as recorded history, long before the printing press, before the wheel was common, before cities were anything more than small clusters of mud and stone. And yet someone, somewhere in that vast quiet world, sat down and noticed something. Noticed that the mind, when given the right conditions, could settle, could become something other than its usual rushing, worrying, planning self. Could, with patience and practice, open into something that felt, to them, like clarity, like peace, like a kind of coming home. Taoist practices in China were exploring similar territory not long after, and Buddhist meditation traditions were developing their own rich and detailed understanding of the mind roughly 1,000 years into that same era. These were not fringe ideas. They were central to entire civilizations, woven into medicine, philosophy, daily life, and the understanding of what it meant to be human. For most of recorded history, the evidence for meditation's effects was experiential. People practiced, and people reported feeling different, calmer, more present, more able to meet difficulty without being overwhelmed by it. The reports were consistent across centuries and cultures, which is itself a kind of evidence. But it was not the kind of evidence that satisfied the modern scientific mind. That began to change in the latter half of the 20th century. And the story of how it changed is, in its own quiet way, a remarkable one. In the late 1970s, a molecular biologist named John Kabat-Zinn was working at the University of Massachusetts Medical School. He had a background in both science and Zen practice, and he had been sitting with a question for some time. The question was this: could the ancient tools of meditation be translated into a form that modern medicine could study, and that ordinary people in pain, people with anxiety, people in pain, people with anxiety, Pithu, who had never heard of Buddhism and had no interest in it, could actually use? He believed the answer was yes, and so he built something. He called it mindfulness-based stress reduction, and it was, at its heart, a structured 8-week program that taught people to pay attention to the present moment without judgment. No robes, no incense required, no philosophical framework beyond the simple, patient practice of noticing. The results were interesting enough to attract other researchers. And slowly, through the 1980s and into the 1990s, the scientific study of meditation began to gather real momentum. Neuroscientists started asking questions that would have seemed quite strange to earlier generations. Not just, does meditation help people feel better, but what is it actually doing to the brain? The tools they needed were becoming available. What they found was not what most of them expected. One of the most famous early encounters between neuroscience and long-term meditation practice happened in a laboratory in Wisconsin. Richard Davidson, a neuroscientist at the University of Wisconsin, Madison had been studying the relationship between brain activity and emotion for years. He had developed ways of measuring something he called affective style, the characteristic way a person's brain responds to positive and negative experiences. Through a mutual connection, Davidson was introduced to Mathieu Ricard. Ricard was a French-born molecular biologist who had, decades earlier, left a promising scientific career to become a Buddhist monk in the Himalayan tradition. He had spent years in intensive retreat. He had meditated, by the time Davidson met him, for tens of thousands of hours. Davidson's team connected 256 electrodes to Ricard's skull and asked him to meditate on what his tradition called compassion, a state of open, unconditional goodwill toward all beings. And then they watched what happened. The results, Davidson later said, were unlike anything the neuroscience literature had previously recorded. The activity in Ricard's left prefrontal cortex, a region associated with positive emotional states, was so far outside the normal range that the researchers initially wondered if something had gone wrong with their equipment. The ratio of left to right prefrontal activity in Ricard's brain was the most extreme they had ever measured. Davidson described it as an abnormally large capacity for joy. He noted that these results had never been reported before in the neuroscience literature. It was a quiet but significant moment. Here was a person whose brain had been genuinely, measurably transformed by decades of deliberate mental practice. The transformation was not metaphorical. It was visible in the data. And Ricard was not alone. As Davidson and his colleagues studied more long-term practitioners, they found similar patterns, not identical, but clearly pointing in the same direction. The question became not whether meditation changed the brain, but how. And how quickly. And what, exactly, was being changed. To understand what meditation does to the brain, it helps to spend a moment with the brain itself, not as a technical object, but as a landscape. A soft, ancient, deeply complex landscape that has been shaped over millions of years of evolution and that continues to be shaped throughout a human life by experience. The brain is not fixed. That is perhaps the most important thing science has learned about it in the last few decades. The old idea that the brain was essentially finished developing by early adulthood and that what you had was more or less what you were stuck with, turned out to be wrong. This capacity is called neuroplasticity, and it is the foundation of everything meditation does to the brain. When you sit quietly and return your attention, again and again, to the present moment, to the breath, to the body, to the simple fact of being here, you are not just resting, you are training. You are, with great patience and very little effort, reshaping the neural landscape of your mind. Several regions of the brain are particularly involved in this reshaping. The prefrontal cortex sits at the front of the brain, just behind your forehead. It is the part of you that plans, that decides, that holds conflicting ideas in mind at the same time. It is involved in attention, in self-control, in what scientists call executive function, the ability to direct your own mental resources. Regular meditators tend to show increased activity in the prefrontal cortex, and with long-term practice, the grey matter there. The actual tissue, the neurons and their connections, becomes denser. There is a structure deeper in the brain called the amygdala. It is small, roughly almond-shaped, and it is one of the oldest parts of the brain in evolutionary terms. Its primary job is to detect threat, to scan the environment and the contents of your own mind for anything that might be dangerous, and to trigger the body's alarm response if it finds something. In most people, the amygdala is extremely active. It is, in many ways, the engine of anxiety. What meditation does to the amygdala is one of the most well-documented findings in this entire field. It makes it smaller. It reduces its activity. After just 8 weeks of mindfulness practice, not years, not decades, but 8 weeks, researchers have measured significant reductions in amygdala volume and reactivity. The alarm system quiets down. The brain's threat detection machinery becomes, over time, less trigger-happy. This is not a small thing. For anyone who has ever felt the physical grip of anxiety, the chest tightening, the thoughts spiraling, the body bracing for something that never quite arrives. The idea that a daily practice of sitting quietly could genuinely, measurably reduce the size of the structure responsible for that response is worth holding for a moment. The hippocampus is another region deeply affected by meditation. It is involved in memory, in the formation of new memories and the retrieval of old ones, and it is also involved in emotional regulation. The hippocampus is particularly vulnerable to the effects of chronic stress. The hormone cortisol, released during stress responses, can actually damage hippocampal cells over time. People who have experienced prolonged stress or trauma often show reduced hippocampal volume. Meditation appears to reverse this. Studies using MRI imaging have shown increased gray matter density in the hippocampus following meditation training. One study using an 8-week mindfulness-based stress reduction program found measurable increases in cell density specifically in the left hippocampal region. The brain, given the conditions that meditation creates, begins to repair and grow. And then there is a network that has become one of the most interesting areas of research in all of neuroscience. The default mode network. This is a collection of brain regions that become active when you are not focused on any particular task. When your mind wanders. When you are thinking about yourself, rehearsing past conversations, imagining future scenarios, planning, ruminating. The default mode network is, in a sense, the home of the wandering mind. The place your brain goes when it is left to its own devices. For many people, the default mode network is not a peaceful place. It is where the anxious thoughts live, where the regrets settle, where the worries about tomorrow take up residence. Research has consistently linked overactivity of the default mode network with rumination, depression, and anxiety. Meditation reduces its activity, not by suppressing it. The mind is not forced into silence, but by gently, repeatedly redirecting attention away from self-referential thought and back toward the present moment. Over time, experienced meditators show significantly reduced default mode network activity, not just during meditation, but as a baseline feature of their brain's operation. The wandering quiets down. The rumination loses some of its grip. It is worth pausing here, in the quiet of wherever you are reading or listening to this, to notice something. Everything described in this chapter, the growth of the prefrontal cortex, the quieting of the amygdala, the healing of the hippocampus, just returning of the default mode network. These are not effects that require extraordinary effort or unusual talent. They emerge from the simple, patient, repeated act of sitting down and returning attention to the present moment, again and again, without judgment, without urgency, just returning. There is something very gentle about that, something almost tender. The brain, it turns out, responds to tenderness. In the summer of 2018, 12 boys and their football coach entered a cave system in northern Thailand. The cave was called Tham Luang, and it was, by most measures, beautiful, a network of limestone chambers and passages that stretched for kilometers beneath the hills. What happened next was followed by the entire world. Monsoon rains arrived faster than expected, flooding the passages behind them. The group was trapped deep inside the mountain in complete darkness, with no food, no communication with the outside, and no certain knowledge that anyone knew where they were. They were found 9 days later, alive. They survived for more than 2 weeks before the rescue was complete. In the days after the rescue, journalists and researchers asked how they had managed. How had 12 children and a young man survived in the dark and the cold and the silence without descending into complete terror? The answer had a great deal to do with meditation. Ekapol. Chantawang had spent several years as a Buddhist monk before becoming a football coach. He had learned through years of practice how to sit with discomfort, how to remain present in difficult circumstances, how to let the mind settle rather than spiral. In those dark chambers, he taught the boys to meditate. He taught them to sit still, to breathe, to conserve their energy, and to stay calm. He taught them, in the most literal possible sense, how to survive by going inward. The story is extraordinary on its own terms, but it points to something that the science also confirms, that meditation is not merely a tool for well-being in comfortable circumstances. It is a genuine capacity for meeting difficulty. A way of training the nervous system to remain functional, to remain present, to remain human, even when conditions are as far from comfortable as they can possibly be. The cave rescue brought meditation to the attention of millions of people who had never thought much about it. But in research laboratories around the world, scientists were quietly discovering that the effects of meditation on the brain could emerge far more quickly than most people assumed. At the University of California, San Diego, researchers ran a study that produced results both remarkable and quietly moving. They enrolled participants in a week-long program of intensive meditation and mind-body practices. 7 days. Just 1 week. And then they looked at what had changed. The changes were measurable across multiple systems. Brain efficiency had improved. Immune signaling, the body's ability to communicate within its own defensive network, had been enhanced. The blood of participants showed increased levels of endogenous opioids, which are the body's own natural pain-relieving chemicals. There was evidence of promoted neuron growth and a stronger connectivity between brain regions. Perhaps most surprising was what the researchers found when they looked at the overall pattern of brain activity. 7 days. The brain, it seems, is always ready to begin changing. It is waiting in its patient way for the right conditions. Around the same time, researchers at the Icahn School of Medicine at Mount Sinai were doing something that had rarely been attempted before. They were using intracranial electroencephalography, recordings taken not from the surface of the scalp, but from electrodes placed directly within the brain tissue itself, to look at what meditation was doing in the deepest brain regions. What they found was that meditation induced measurable changes in the strength and duration of specific electrical rhythms in both the amygdala and the hippocampus. Beta waves and gamma waves, patterns of neural activity that are known to be disrupted in mood disorders like depression and anxiety, were altered in ways that suggested genuine therapeutic relevance. The brain, at its deepest accessible level, was responding to the practice of stillness. This research was published in the Proceedings of the National Academy of Sciences in early 2025, and it represented something genuinely new. For the first time, scientists had direct evidence of meditation's effects in the deep brain structures where so much of human emotional life is rooted. There is a chemistry to meditation that is worth spending some time with, not in a technical way. The names of molecules need not be remembered. but in the way that understanding what is happening inside you as you sit quietly might make the sitting feel like something more than just sitting. When you meditate, the brain changes what it releases. The stress hormones, cortisol, adrenaline, the chemical messengers of urgency and alarm, decrease. Their presence in the bloodstream drops. The body's alarm system, running at a lower setting, no longer floods the tissues with the molecular equivalent of emergency signals. At the same time, other chemicals rise. Serotonin, which is associated with mood stability and a quiet sense of well-being, increases. Dopamine, the brain's reward and pleasure signal, rises as well. And GABA, a neurotransmitter whose primary function is to reduce neural excitability, to slow things down, to bring a kind of chemical calm to the brain's electrical activity, also increases in meditators. This is not a small or marginal effect. These are the same neurotransmitter systems that many pharmaceutical treatments for anxiety and depression target. The difference is that meditation shifts them through the brain's own processes, through the body's own chemistry, without external intervention. The brain also produces something called brain-derived neurotrophic factor, or BDNF. This is a protein that supports the growth, maintenance, and survival of neurons. It promotes neuroplasticity, the brain's ability to rewire and adapt. It is, in a sense, fertilizer for the mind. Meditation increases its production. The brain, under the influence of regular stillness, creates more of the very substance that allows it to grow and change. There is also the question of what meditation does to the brain over time, not over weeks or months, but over years and decades. What happens to the brain of someone who has been meditating regularly for a long, long time? One answer comes from research on grey matter, the tissue that contains the cell bodies of neurons, the processing centers of the brain. Grey matter naturally declines with age. This is a normal part of getting older. From roughly the mid-20s onward, the brain gradually loses grey matter volume, and this loss is associated with the cognitive changes that come with aging. Slower processing, reduced memory capacity, decreased memory capacity, reduced memory capacity to hold multiple things in mind at once. Meditators lose grey matter too, but they lose it more slowly. A study published in 2015 found that meditators showed a significantly slower rate of age-related decline in grey matter volume in the putamen, a region involved in learning and attentional processing. The brains of long-term meditators were, in a measurable sense, aging more slowly than the brains of people who did not meditate. A related finding came from research on cortical thickness, the depth of the outer layer of the brain where much of the highest level processing happens. Long-term meditators show greater cortical thickness in regions associated with attention and sensory processing. The brain, exercised through meditation, maintains more of its structure over time. This is a quiet gift, not a dramatic one, not something you would feel on any particular day. But across a lifetime, the cumulative effect of a daily practice of stillness may be a brain that remains more capable, more resilient, more fully itself for longer. And there is one more dimension of meditation's effect on the brain that belongs in this chapter, because it is the one most relevant to why you are here, tonight, in the dark, listening to this. Sleep. The relationship between meditation and sleep runs deeper than most people realize. It is not simply that meditation helps you relax and relaxation helps you sleep, though that is true. The relationship goes all the way down to the level of brainwaves, the electrical rhythms that the brain produces as it moves through its various states. During meditation, the brain tends to shift towards slower wave patterns. Beta waves, the fast, active rhythms associated with thinking, problem-solving, and the busy work of the waking mind, decrease. Alpha waves, which are associated with calm and relaxed wakefulness, increase significantly. Many meditators move into theta waves during deeper practice, the slow, dreamy rhythms that are also present in the earliest stages of sleep, in the soft borderland between waking and dreaming. With consistent practice, these shifts become more than temporary. The brain begins to adopt these slower patterns as a kind of baseline. Alpha waves, over time, can become the dominant rhythm of a meditating brain even outside of formal practice sessions. Research from 2016 found something particularly beautiful in long-term meditators who had just completed intensive training. When these practitioners fell asleep, their brains showed increased slow-wave activity and more sleep spindles, brief bursts of oscillating neural activity that appeared during the transition from lighter to deeper sleep. Sleep spindles are considered markers of the brain's consolidation processes, the nightly work of strengthening memories, integrating new learning, and maintaining the neural architecture that allows us to function well when we are awake. The meditating brain, even in sleep, is doing something different, something more efficient, something more restorative. So we have traveled a long way tonight, from a Sanskrit word meaning to remember, spoken in a world we can barely imagine, 3,500 years distant, through laboratories in Wisconsin and Massachusetts and California and New York, into a flooded cave in northern Thailand where a young man taught children to be still in the dark. We have visited the prefrontal cortex, growing denser with practice. We have watched the amygdala quiet down, shrinking slowly over 8 weeks of unhurried attention. We have seen the hippocampus, damaged by stress, beginning to heal. We have observed the default mode network, that restless, self-referential chatter growing softer and more distant in the minds of those who have learned to sit with themselves. We have touched the chemistry of it, the cortisol falling, the serotonin rising, the BDNF encouraging new growth in the soil of the mind. We have noticed the slow, patient preservation of grey matter across a lifetime of practice. And we have followed the brainwaves down from the busy beta of the waking day, through the calm of alpha, into the soft threshold of theta, and finally into sleep, where the meditating brain continues its quiet work. None of this requires anything extraordinary of you. It does not ask for hours of practice or years of training before anything changes. The research suggests that change begins quickly, sometimes within days, sometimes within a single session. The brain is responsive. It is waiting for the opportunity. It has been waiting, in some sense, for as long as you have been carrying whatever you are carrying. If today was hard, and some days simply are, without much reason and without much warning, you do not have to meditate tonight. You do not have to do anything. You are already here, already still, already letting the day recede behind you. That is enough. More than enough. The body knows how to rest. The brain knows how to slow. These are ancient capacities built into you over millions of years of evolution. They are not broken. They are simply, sometimes, waiting to be given a little space. The Sanskrit word smriti. There is something in the fact that human beings have been practicing this for 3,500 years. That monks in the Himalayas and scientists in Wisconsin and 12 children in a dark cave have all found, through very different paths, the same quiet truth that the mind, given the right conditions, can settle into something vast and soft and deeply restful. That capacity is yours too. It has always been yours. It does not need to be earned or achieved. It is simply there, underneath everything, patient and unhurried, the way deep water is still even when the surface is rough. The research will continue. New studies will be published. New brain regions will be mapped, new mechanisms uncovered, new questions raised. Science is always moving, always asking the next question. But the practice itself is ancient and slow and in no hurry. It has been here longer than the laboratories. It will be here longer than the laboratories. And tonight, that is a comforting thought. That somewhere underneath the noise of the world, underneath the busyness of the day just past and the day not yet arrived, there is something still. Something that does not need to be created or maintained. Something that simply is. You can rest toward it now if you like. There is nothing more to understand, nothing to figure out. The words are done. And so we leave it here, in the quiet. Somewhere behind you, the day has already grown small and distant. The brain is beginning its own slow work. The consolidation, the repair, the soft electrical rhythms of rest. Let it do what it knows how to do. You have been still enough tonight. Sleep well. What made Mathieu Ricard's case so striking to Davidson was not simply the numbers, remarkable as they were. It was what Ricard reported feeling during the scans. Not effort. Not concentration in the way most people understand that word. Davidson's team went further. They asked Ricard to shift rapidly between different meditative states, to move from compassion to a neutral resting state and back again on command, while the electrodes recorded everything. What they observed was that Ricard's brain responded to these transitions with a speed and precision that was, again, outside anything they had seen in non-meditating subjects. This finding had implications that went well beyond the study of meditation. It suggested that the brain's emotional states were not fixed weather systems that simply arrived and departed on their own schedule. They were, at least in part, skills. Learnable. Trainable. The capacity to move from distress into equanimity was not a personality trait you either possessed or did not. It was something closer to a muscle. Something that responded to practice. Davidson would later write that this realization shifted his entire understanding of what the science of emotion was actually studying. He had spent his career mapping the brain's emotional responses as if they were relatively fixed features of a person's neurology. Ricard's brain suggested something else entirely. It suggested that the emotional brain was not a given. It was, to a degree that surprised even the scientists studying it, a work in progress. An ongoing project. Something that a human being could, with patience and practice, genuinely shape. The collaboration between Davidson and the Tibetan Buddhist community deepened from there. The Dalai Lama, who had long believed that the dialogue between contemplative practice and modern science could be mutually enriching, actively encouraged senior monks to travel to Madison and participate in studies. Over the following years, dozens of long-term practitioners, some with 20,000 hours of meditation, some with 40,000, submitted to brain scans, blood draws, and psychological assessments. They did so, by all accounts, with great curiosity and good humor. The results across this larger group confirmed and extended what Ricard's data had suggested. The brains of long-term meditators were consistently different from control subjects in ways that correlated with the number of hours practiced. More hours of practice corresponded with more pronounced changes. That last point mattered enormously. One of the standing objections to early meditation research was the possibility that people who meditated a great deal were simply different to begin with, more emotionally stable, more neurologically fortunate, and that their brain differences reflected their nature rather than their practice. The dose-dependent relationship helped address this. If the changes scaled with hours of practice, there is a region of the brain called the insula, tucked within the folds of the cortex, roughly above and behind each ear. The insula is involved in something called interoception, the brain's awareness of the body's internal state. Meditators show increased thickness in the insula and increased activity there during practice. This is thought to be one of the reasons that experienced meditators often report a heightened sensitivity to their own emotional states, not in a way that makes them more reactive, but in a way that gives them more information earlier. They notice the first whisper of anxiety before it becomes a shout. They feel the beginning of a stress response while it is still manageable. The insula, trained through years of body-centered awareness, becomes a more sensitive instrument. There is something quietly practical about this. One of the most difficult aspects of emotional difficulty, anxiety, sadness, the grinding accumulation of low-level stress, is that it often builds unnoticed. You realize you are overwhelmed only after you are already overwhelmed. The insula, developed through meditation, offers something like early warning. A gentler, earlier awareness that something is shifting, that the body needs attention, that the mind might benefit from a moment of stillness before things become harder to navigate. The anterior cingulate cortex is another region that receives a great deal of attention in meditation research. It sits at the front of the cingulate gyrus, a curved structure that arcs over the center of the brain, and it is involved in a range of functions that are deeply relevant to what meditation trains. Error monitoring. The ability to notice when the regular meditators show increased gray matter density in the anterior cingulate cortex. They also show increased activity there during tasks that require sustained attention. The region appears to become more efficient, better at doing its job more quickly with less effort. In practical terms, this translates into something that meditators frequently report and that non-meditators frequently report and that non-meditating observers sometimes find difficult to believe, that sustained attention becomes, over time, less effortful. Not easier in the sense that the skill becomes more natural. There is also a structure called the posterior cingulate cortex, which sits further back along the same curved formation. This region is considered a central hub of the default mode network, the wandering, self-referential thinking that was described earlier. Experienced meditators show reduced activity in the posterior cingulate cortex both during meditation so significantly during rest. The quieting of this region is thought to underlie the reduction in rumination that meditators consistently report. The mind still wanders, but it wanders less. What is remarkable about this whole geography, the prefrontal cortex, the amygdala, the hippocampus, the insula, the cingulate cortex, is how coherent the picture is. Each of these regions plays a role in the experience of suffering or well-being. Each of them responds to meditation in a direction that would, if you were designing a brain for greater resilience and calm, be exactly the direction you would want. It is not as if the research has found that meditation helps some brain regions while inadvertently harming others. The effects, as far as the science has been able to determine, are consistently in the direction of greater balance. The brain, given stillness, moves toward health. That is the simple, patient truth at the center of all of this research. There is a detail about the Thai cave rescue that is easy to pass over, but worth holding gently. In the days when the boys were trapped and the world did not yet know whether they were alive, Ekapol Chanthawong made a decision. He gave his own food to the children. He ate almost nothing for the duration of their confinement. When rescue divers finally reached the group, Chanthawong was the most physically depleted of them all. He had, in a quiet and entirely deliberate way, placed the children's survival above his own. Later, when asked how he had managed both the physical privation and the responsibility of keeping 12 young people calm in absolute darkness. He spoke about his years in the monastery, about learning to sit with discomfort without being consumed by it, about the understanding that the present moment, however difficult, was survivable, that the mind's tendency to project forward into imagined catastrophe was the real enemy, not the darkness itself. This is not a metaphor. It is a description of something the neuroscience confirms. The suffering that comes from anxiety is largely prospective. It lives in the future, in the imagined versions of what might happen. The practice of meditation, at its core, is the practice of returning to what is actually happening now. And what was actually happening in that cave, moment by moment, was that the children were alive, that the air was breathable, that the body could be stilled, that another breath was possible. The coach held that reality steady for his team in the dark for 9 days. That is an extraordinary thing to be able to do. And it was not an accident. It was the fruit of years of quiet practice, done long before anyone could have imagined it would ever be needed in that way. In the aftermath of the rescue, Chanthawong ordained briefly as a monk again. A traditional Thai Buddhist practice following a significant event, a way of dedicating merit to those who had helped. He spent time in a monastery, sitting in the familiar stillness that had carried him through the cave. There is something moving about that image. The man who had taught children to be still in the dark, returning to stillness himself in gratitude. The cave story became famous, partly because of its scale, the global attention, the international rescue effort, the weeks of uncertainty. But smaller versions of the same story play out every day in quieter places. People who have developed a meditation practice find, in moments of genuine difficulty, that something is available to them that was not available before. Not an absence of fear or pain, but a kind of inner room they can step into. A place in the mind that the difficulty has not reached. A capacity to remain present and functional even when the circumstances are Research on meditation and pain. Perception offers a particularly clear window into this capacity. Studies using controlled heat stimuli, carefully measured amounts of heat applied to the skin, enough to be painful but not harmful, have found consistent differences between meditators and non-meditators in how pain is experienced and reported. Meditators do not necessarily feel less pain in terms of the raw sensory intensity. The heat registers at roughly the same level. What changes is the relationship to the pain. The unpleasantness, the emotional component, the layer of suffering that sits on top of the raw sensation is reduced. Meditators describe the pain as more neutral, more like information than like assault. The sensation is present, but the story around it, this is terrible. This distinction between the sensation itself and the suffering layered on top of it is one that contemplative traditions have been articulating for thousands of years. The Buddha's teaching on dukkha, often translated as suffering, made exactly this distinction. Pain is inevitable. The additional suffering that comes from resisting, fearing, or narrativizing pain is, at least in part, optional. There is a structure at the end of each chromosome called a telomere. Telomeres are sometimes described as the caps on the ends of shoelaces. They protect the chromosome from fraying and damage during cell division. Each time a cell divides, the telomeres shorten slightly. When they become too short, the cell can no longer divide properly and begins to deteriorate. Telomere length is considered one of the most reliable biological markers of cellular aging. Longer telomeres are associated with longer, healthier lives. Shorter telomeres are associated with age-related disease and earlier death. An enzyme called telomerase repairs and maintains telomeres. And meditation, several studies have now found, increases telomerase activity. This finding, when it first emerged from the work of researchers including Nobel Prize-winning molecular biologist Elizabeth Blackburn and her collaborators, was received with considerable surprise. The idea that a mental practice, something done entirely in the realm of thought and attention, could have measurable effects at the level of chromosomal biology was not something most scientists had anticipated. The mechanism is thought to involve the stress response. Chronic stress accelerates telomere shortening. Cortisol and other stress hormones, present at high levels over long periods, appear to damage telomeres directly. Meditation reduces chronic stress. It reduces cortisol. And in doing so, it appears to slow the cellular aging process at one of its most fundamental levels. This is not a claim that meditation extends life in some dramatic or certain way. The research is still developing, and the effect sizes, while real and consistent, are modest. But the direction of the finding is clear, and it is consistent with a broader picture that has been building across decades of research. Meditation is not just changing how you feel, it is changing the biology of your cells. A related finding concerns inflammation. Chronic low-level inflammation is now understood to be a driver of many of the diseases associated with aging. Cardiovascular disease, certain cancers, cognitive decline, depression. The body's inflammatory response, like the amygdala's threat detection, is designed to be activated briefly in response to genuine threats and then to subside. In many people living under chronic stress, it never fully subsides. It runs at a low, constant level, doing slow damage over years and decades. Meditation reduces inflammatory markers in the blood. Studies measuring cytokines, the signaling molecules that regulate inflammation, have found consistent reductions in pro-inflammatory cytokines following meditation training. The body's inflammatory alarm, like the amygdala, learns to run at a lower setting. What is quietly remarkable about all of this? The telomeres, the inflammation, the grey matter, the cortisol, is that none of it requires you to believe anything in particular. Meditation research has been conducted in secular settings with participants who had no prior interest in contemplative practice and no particular spiritual inclinations. The effects appear regardless of the meditator's beliefs about what meditation is or why it works. The brain and body respond to the practice itself, to the simple repeated act of returning attention to the present moment. There is something democratizing about that. The ancient practices developed in monasteries and hermitages, refined over centuries of dedicated contemplative life, turn out to contain something that belongs to everyone. Not just to monks or philosophers or people with hours of daily leisure. The research consistently suggests that even modest amounts of practice, 20 minutes a day or less, produce measurable changes in the brain and body over time. A calm mind, a more resilient nervous system, a brain that ages a little more slowly, a body that carries a little less of the accumulated weight of chronic stress, a slightly greater capacity to meet difficulty without being entirely consumed by it. These are not small things. They are, in fact, among the most important things a human being can have. And they are available, in some measure, to anyone who is willing to sit quietly for a while and simply return, again and again, to the breath. There is a researcher named Sarah Lazar at Massachusetts General Hospital who has spent years studying the structural effects of meditation on the brain. One of her most cited findings involves the relationship between meditation and cortical thickness in a region of the prefrontal cortex associated with attention and decision-making. In most people, this region thins with age, part of the general decline in grey matter that begins in the mid-20s. In Lazar's meditating subjects, 50-year-old practitioners had the same cortical thickness in this region as 25-year-olds who did not. When this finding was first reported, it attracted a great deal of attention and also a great deal of appropriate scientific caution. Correlation is not causation. Perhaps the meditators had always had thicker cortices. Perhaps something else about their lives, their diet, their sleep, their social connections was responsible. But the finding has since been replicated and extended in multiple labs. And on quiet nights like this one, there is something deeply restful about that knowledge. Not because you need to do anything with it right now, but because it suggests that the body and mind you carry, whatever state they are in, however tired, however worn by whatever this particular season of life has brought, are not finished changing, are not finished changing, are not fixed, are still, in their patient and ancient way, capable of moving towards something gentler,